How do we integrate exponential functions? Well, if you remember, last screencast we learned that the derivative of e to the x is itself e to the x. So if we just reverse that, that means the integral of e to the x is e to the x, and don't forget to put your plus c on there if it's an indefinite integral. Okay? So let's do some examples. Alright, how about x squared e to the x cubed dx? Well, we're going to do a u du substitution. We're going to let u equal the exponent, which means du is 3x squared dx. And I have a 1x squared dx. I need a 3, so I'm going to do integral 3x squared e to the x cubed dx. Since I multiplied inside by 3, I'm going to divide outside by 3. So now I have a 3x squared dx, which I can replace with du, and x cubed is u. So I have e to the u du. That fits the pattern we're looking for. The antiderivative of e to the u is e to the u. And putting it back in terms of x, my final answer is 1/3 e to the x cubed plus c. Okay, how about this one, the integral of cosine x e to the sine x dx? Once again, we'll do a u du substitution. We'll let u equal the exponent, which means that du is the derivative of sine. And there we go. Cosine x dx is right there waiting to turn into du for us. So I'm going to get the integral of e to the u du, which is e to the u plus c. Putting it back in terms of x, that's e to the sine x plus c. Alright, so let's look at this problem. It says that the median waiting time in minutes for people waiting for service in a convenience store is given by the solution of this equation right here. We're going to solve that equation. In other words, we're going to find out how many people need to be in the store for the median waiting time to be 1/2. Okay? So we're going to have the integral from 0 to x. And I'm going to go ahead and move that 0.1 out front here. And I've got e to the negative. No, I changed my mind. Hang on just a minute. I'm thinking ahead here. We're going to do the integral from 0 to x, 0.1 e to the negative 0.1 t dt. Okay, so I'm going to let u equal the exponent, which means that du is negative 0.1 dt. So you see why I left that 0.1 inside? Because all I have to do now is make that a negative and then make it a negative outside. And negative 0.1 dt is du. Alright, so I've got the negative integral of e to the u du, and that is going to equal negative e to the u, which is negative e to the negative 0.1 t. Okay, well remember that this was a definite integral. So what I've got is negative e to the negative 0.1 t. We're going to evaluate that from 0 to x, and it's supposed to equal 1/2. So that's what we need to solve. Okay, so I've got negative e to the negative 0.1 x minus negative e to the negative 0.1 times 0 equals 1/2. That's negative e to the negative 0.1 x minus a negative is plus, and e to the 0 is 1. Okay, so now I have negative e to the negative 0.1 x equals 1/2 minus 1, which is negative 1/2. That means positive e to the negative 0.1 x equals positive 1/2. And now we just have a simple exponential equation to solve. I'm going to take the natural log of both sides, and the natural log of e to the negative 0.1x is negative 0.1x. And I get x equals the natural log of 1/2 divided by negative 0.1. Okay, calculator time. natural log of 1/2 divided by negative 0.1. And that's our answer. It's going to take about 7 people for us to reach that median waiting time of half a minute.